Welcome to the second lesson of ICT systems. This part will introduce computer networks. Let's clear some terms. Computer network is a connection of at least two computers which can interact and change information. The Internet is not a computer network. It can be imagined as a net of nets. The World Wide Web is also not a computer network. It's a distributed system which is served by the Internet. A distributed system is a system with multiple components located on different machines that communicate and coordinate actions in order to appear as a single system to the end user. The machines that are a part of a distributed system may be computers, physical servers, virtual machines, containers, or any other node that can connect to the network. Each of the nodes contains a small part of distributed operating system software. Hence, the main difference between computer networks and distributed systems can be found in software rather than in hardware. How a distributed system works? Well, hardware and software architectures are used to maintain a distributed system. Everything must be interconnected. Distributed systems have endless use cases. Just to mention a few of them: electronic banking systems, massive multiplayer online games, and sensor networks. There are lots of fields where networks are used. For example, it can be used in business applications, governance applications, home applications, personal applications, or mobile applications. Business utilization can be source sharing, conventional communication, video-based communication, electronic commerce, and different online banking solutions. You can see examples in the brackets. Governance utilization can be divided into four categories. G2C is a two-way communication for administration, electronic voting, digital signature, and others. G2E is used for e-tax service, e-payroll, e-training, e-learning, and many others. G2B is used for e-tender box, e-procurement program, e-support for business, and so on. And finally, G2G is used for government transactions, digital democracy, interaction among governmental agencies, and others. Home applications can be remote data access, conventional communication, video-based communication, interactive pastime, e-commerce, smart home solutions, and many others. We can categorize networks from different points of views. These would be the mode of data transfer, the local arrangement of devices, the way of communication, and the type of connection. Let's see them. According to the mode of data transfer, we can differentiate casting networks and point-to-point networks. You can see an example of casting network on the left side picture. For example, radio and television are typical casting networks. Casting networks usually perform one-way communication. On the right side picture, you can see point-to-point networks, which are usually conventional local area networks. According to local arrangement, 5 network types might be differentiated. Personal area network is not a real computer network because it usually contains a computer and its periphery, such as printer, scanner, and other hardwares. Local area network is the smallest computer network, which size is generally limited to a room or an office or a building. Metropolitan area network is one size bigger than local network. Its size is typically limited to huge buildings or even whole cities. Metropolitan network connects several local area networks. The wide area network connects metropolitan networks. Its size can spread to whole countries or continents. And the greatest network is global area network, which connects the whole planet. If we analyze networks from the perspective of the way of communication, then 3 types can be listed. The first one is simplex network. This means that the communication happens only in one direction. Typical example is a casting network, like radio or television. The second type is half-duplex network. In a half-duplex network, communication happens in both directions, but only one direction is active at a time. A typical example is wireless network because, unfortunately, the air can only relay data in one way without interference. And our last type is full duplex network, which can relay data in both directions at the same time. A typical example is Ethernet network. The next division is usually used in phone networking. We can differentiate fixed line network and connected line network. At fixed line network, connection is always active, hence it is very resource wasting. At connected line network, connection is only active during data transfer. Here, connection center helps in establishing connections. Finally, our last listing is based on topology. Topology means the way in which shape devices are connected. We should differentiate ring, line, bus, tree, star, fully or partially connected mesh network. Just to mention, today's Wi-Fi uses star topology. However, the most modern topology is mesh, which can be backbone for future networks. In order to understand the network's operation, the architecture needs to be explained. Network architecture is structured, layered, and protocol-based backbone of network's operation. As you can see on this picture, 2 host machines are connected. At the bottom of architecture, the physical layer is always placed, which can be a cable or the air. So this is where data is physically transferred. The upper layers usually describes some functionalities that enables proper operation of a network. A layer can communicate with its upper and lower neighbor or with another host's layer on the same level. These same level layers can communicate owing to protocols. Let's compare the two most famous reference models. The first one is the so-called OSI model. The second one is the TCP/IP model. You need to know that these models are only theoretical models and none of them is perfect independently. However, these models give the backbone of today's network. In practice, we use the combination of before presented models and we get a 5-layer model which has physical layer, data link layer, network layer, transport layer, and application layer. Let's see how they work. The physical layer is where data is transferred. Moreover, this layer converts electric signs to bits and transmits them to upper level. It has to ensure voltage levels, bit values, transmission time, and duplexity as well. The data link layer uses some functional units such as media access control and link layer control unit. This layer handles data lines between hosts and arranges bits into frames. As a matter of fact, the start and the end of frames have to be indicated by this layer as well. Network layer controls subnetwork issues such as traffic jam or sending priority. This layer performs routing using IP addresses and has to correct any addressing error. It handles packages that are arranged from frames. The transport layer is end-to-end layer from the source to the destination. It handles data which is organized from packages. The transport layer ensures data flow control and error correction as well. The application layer is the highest layer in architecture, which enables a variety of protocols, such as HTTP or HTTP secured, FTP, and these are used for content transfer. SMTP, IMAP, and POP3 are used in messaging. DHCP and DNS are networking related protocols for IP utilization. SSH and Telnet are remote access protocols. In the 21st century, wireless networks play the most relevant roles. Let's see a few of them. The first mobile network was GMS. However, today we mainly use 3G, 4G, or even 5G. The GPS is also a wireless network using satellites and ground receivers. The well-known Wi-Fi is used in almost every household and office. Low-power wireless networks are used generally in industry, however, they can be used in customer applications as well. And mesh network is a technology that allows wireless networks to cover huge areas, even whole cities. This technology represents the future of networking. On this picture you can see how certain frequency ranges are distributed. And we will continue with wireless networks in the next lesson. Thank you for your attention.